To understand why we carry out certain tasks within Revit, it is important that you understand the fundamentals of a building. This is a huge topic, so I'll briefly cover the main areas. Generally, a building has two major components, the substructure and the superstructure. The substructure is part of the building that is built below the ground levels, whereas the superstructure is everything else that is above ground. The foundation, which is the substructure of the building, transfers the loads from the superstructure to the underlying soil. Foundations are generally broken into two categories, shallow foundations and deep foundations. The different shallow foundation types are individual footing or isolated footing, combined footing, strip foundation, rafter or mat foundations. The different deep foundation types are pile foundations and drilled shafts or caissons. Generally, the foundations are made of concrete and reinforced with steel rebar. Then we have the superstructure. The superstructure is the portion of the building which is constructed above the ground level. It includes columns, beams, floor slabs, finishes, doors, windows, and anything else above ground. Finally, the building finish, which is part of the superstructure. When talking about the finishes, we can be referring to both the external and internal parts of a building. Finishes serve many purposes. They can protect the element they finish from impact, water, frost, corrosion, abrasion, and most importantly, being decorative. The building's finish can define its character. Architectural finishes can refer to a variety of textures, solidities, colors, and materials, and refer to hard and soft permanently fixed finishes such as plaster or render, and other surface coatings such as paint and wallpaper. This, of course, is a very brief overview of the fundamentals of a building. There is so much more to say, but we must focus on the tool which will bring our construction project to life. Most of the terms used to identify objects in Revit are common industry standard terms. However, some terms are unique to Revit. Understanding the following terms is crucial to understanding the software. In Revit, the project is the single database of information for your design, the Building Information Model, or what is known as BIM. The project file contains all of the information for the building design, from the geometry to the construction data. This information includes components used to design the model, views of the project, and drawings of the design. By using a single project file, Revit makes it easier for you to alter the design and have changes reflected in all associated areas, be it the plan view, elevations, section view, schedules, and so on. Having only one file to track also makes it easier to manage the project. You build your Revit project by what are called elements. Revit uses three types of these elements in the project: model elements, which are doors, walls, and stairs; datum elements, which are grids and levels; or view-specific elements, which are tags, texts, and dimensions. Elements are then organized into groups called categories. A category is a group of elements with similar properties and functionality. For example, all of the walls in Revit are grouped into the walls category. The same applies to our doors, windows, and columns. Each category is then further organized into what are called families. A family is a subgroup which further sorts the elements into a category into specific groups based on a property. For example, the columns category is broken up into a round column family and a rectangular column family. Each of these families can have several types. A type can be a specific size of that family, such as a 450mm round column or a 600mm round column. These columns will have identical type properties other than the dimensions, and consequently they are grouped into the same family. Each time you place an element into Revit, you have placed what is referred to as an instance of the element. Instances are the actual items, or known as individual elements, that are placed into the project and have specific locations in the building, known as model instances, or on a drawing sheet, known as an annotation instance. So if you have 10 columns of the same type and you want to change the properties of just one column, you can edit the properties of just that one instance, and the changes will only affect the individual element. In today's growing market, architects, engineers, and contractors are using BIM, and here's why. Global trends are making AEC projects more complex, and with the advancements of technology in the construction industry, they are helping industry professionals work more efficiently and effectively. This is where BIM steps in. Building information modeling, known as BIM, is a process that begins with the creation of an intelligent 3D model and enables document management, coordination, and simulation during the entire life cycle of a project. Typically, a BIM project lifecycle consists of these phases: plan, design, build, operation, and maintenance. The power of BIM is how it allows architects, engineers, and contractors to collaborate on coordinated models, giving everyone better insight into how their work fits into the overall project, ultimately helping them to work more efficiently. So, when an element in a model is changed, every view is updated, with the new change appearing in section, elevation, and sheet views. The data can be used in powerful analysis and simulation and include realistic visualizations. You can use the information in the model to improve the design before it's built, reducing costs of on-site errors and costly rebuilds, improve construction timelines and lower project risks, resulting in better project outcomes. Create visualizations that help stakeholders understand what the building will look like before it's built. Owners can use BIM for predictive maintenance, asset tracking and facilities management, and future renovation or deconstruction projects. All these technologies allow for professionals to be better connected, as well as design and work together in all new ways.